Hello everyone, welcome to Geeky Nerd. Today we will begin with the part 3 video of the aptitude topic problems on trains. Before moving into the video, I hope everyone would have become thorough with the previous two videos related to this aptitude topic. If you have not seen those videos, please click on the card or the links in the bio to watch them. In this video, we will be discussing how time taken, distance traveled, and speed gets related with each other when two trains cross each other, and when two trains move in same direction, and when two trains move in opposite directions. Like, share, and subscribe the channel for more interesting concepts and shortcut methods for solving the problems. So without wasting any time, let's move into the video. When two trains move towards each other, their relative speed increases. That is, relative speed is equal to speed of train A plus speed of train B. When two trains move in opposite direction, that is, relative speed becomes additive in nature, and when they move together in same direction, relative speed becomes speed of train A minus speed of train B, or speed of train B minus speed of train A. So we calculated the speed of the trains, that is the relative speed. Now we need to know the formula of distance traveled. As we saw in the first video, whenever a train crosses an object whose length is not negligible, then the distance traveled by the train to cross the object is equal to length of the train plus length of the object. A train A of length 180 meter running by 72 km per hour crosses the other train B, which is running in the opposite direction at a speed of 108 km per hour, and the length is 120 meter. In how much time does the train B cross the train A? So from the question, we can clearly understand that length of train A is equal to 180 meter and length of train B equal to 120 meter. Speed of train 1 is equal to 72 km per hour and speed of train 2 is equal to 108 km per hour. We need to find the time taken by train B to cross train A. So from the question, we clearly understood that both the trains move in opposite direction. Therefore, relative speed is equal to speed of train 1 plus speed of train 2, which is equal to 72 plus 108, which is equal to 180 km per hour. Since the distance is given in terms of meters, we can convert it into meter per second, which is equivalent to 50 meter per second. We know that the distance traveled is equal to length of train 1 plus length of train 2, which is equivalent to 180 plus 120, that is 300 meters. So now we can find out that the time taken by train B to cross train A is equal to distance travelled divided by speed, that is relative speed, which is equal to 300 by 50, which is equal to 6 seconds. Therefore, if a train of length 180 meter running at 72 km per hour tries to cross a train of 108 km per hour with a length of 120 meters, it takes 6 minutes for train B to cross train A. Let us solve one more example to understand this concept. Two trains of same length are running in parallel tracks in opposite direction with the speeds of 65 km per hour and 85 km per hour respectively. They cross each other in 6 minutes. So, it is given that length of train 1 is equal to length of train 2. Therefore, let us assume this as LT. We also know that speed of train 1 is equal to 65 km per hour and speed of train 2 is equal to 85 km per hour. Time taken to cross each other is equal to 6 seconds. From the question we know that both the trains are moving, I'm sorry, from the question it is known that both the trains are moving in opposite direction. Therefore, relative speed is equal to speed of train 1 plus speed of train 2, which is equal to 65 plus 85, which is equal to 150 km per hour. It can be converted into meter per second as 150 into 5 by 18 meter per second. Thus, we know that time taken is equal to distance traveled divided by relative speed. So here distance travel can be written as length of train 1 plus length of train 2. Therefore, LT plus LT, since both of them remains the same, divided by 150 into 5 by 18. Therefore, it becomes 6 into, sorry, 6 is equal to 2LT multiplied by 18 by 750. It implies 750 into 6 is equal to 36 LT. Upon solving, we get LT is equal to 150 meters. Therefore, length of the train 1 is equal to 150 meter and length of the train 2 is also equal to 150 meter. So, with these two questions, we have clearly understood that whenever a train tries to cross another train or another object which is moving, then we need to find the relative speed as well as the distance traveled becomes length of train 1 and length of train 2. Two trains start from same place. We will be asked to find distance and time. Let us consider train A. The train A is starting from station A at a particular time. The speed of train A is equal to S1 km per hour. Now, let us consider another train, train B, starting from the same station A, but after some hours of time t. Let S2 be the speed of train B. Now, we are asked to find the distance from the starting point till the place where both the trains will meet each other. We can utilize the formula of distance is equal to S1 multiplied by S2 multiplied by T, the whole divided by S2 minus S1. Here negative sign is used in the denominator because both the trains are traveling in the same direction. In case, if they want to find the time at which both the trains meet each other, we can utilize the formula time is equal to S1t divided by S2 minus S1. It might be little bit confusing to understand the concept without solving the problem. Hence, we will solve few problems to clearly understand what we had learned now. Two trains leave for Patna from Delhi at 10 a.m. and 10:30 a.m. respectively. The speed of first train is 120 km per hour and that of the second train is 150 km per hour. At what distance from Patna will they meet each other? So from the question, it is clearly given that speed of first train is equal to 120 km per hour. Speed of second train is equal to 150 km per hour. It is also given as the time difference between the starting of train A and train B is equal to 30 minutes, which is equal to half an hour. Thus, we are asked to calculate the distance from Patna at which the train meet each other. So from the concept, we can clearly see that distance d is equal to difference in time multiplied by S1 multiplied by S2 divided by S2 minus S1. Upon substituting the necessary values, we get half an hour, therefore 1 by 2 multiplied by 120 multiplied by 150 divided by 150 minus 120, which will give 18,000 multiplied by 600, which eventually will be 300 kilometers. That is, if two trains leave for Patna at 10 and 10:30 am respectively at a speed of 120 km per hour and 150 km per hour, they both will meet each other at a distance of 300 kilometers from Patna. We learn from the concept that the distance when two trains meet each other is equal to difference in time multiplied by the individual speeds, the whole divided by speed of train 2 minus speed of train 1. Thus, we found out the distance from Patna at which both the trains meet each other as 300 kilometers. In case if the question also asked about the time at which both the trains met each other, it can also be given by the formula S1t multiplied by S2 minus S1. Here t refers to the difference in time, not the actual time which is being asked. On substituting, we get 120 multiplied by 1 by 2, the whole divided by 150 minus 120, which in turn will give 60 by 30, which in turn will give 2 hours. Therefore, the two trains will meet each other after 2 hours from the starting train's time. That is, the train A started at 10 am. By adding 2 hours to the starting time of train A, that is 12 noon, both the trains will meet each other at a distance of 300 kilometers. Let us see the new concept. Two trains start from opposite directions. The distance between the two stations A and B is given as small d. A train starts from A to B at a speed of S1 km per hour and another train starts from B to A at a speed of S2 km per hour. The distance from A at which both the trains will meet can be determined using the formula distance is equal to S1 of D plus S2t divided by S1 plus S2. Here S1 refers to the speed of the first train, S2 refers to the speed of the second train, small d refers to the distance between the two stations, and capital T refers to the number of hours difference at which the second train starts with respect to the first train. Similarly, the time at which both the trains meet can be determined using the formula time is equal to d plus s2t divided by s1 plus s2. Here, on both the formulae denominator, we can see the speeds are added, that is, the relative speed becomes additive in nature. because both the trains move in opposite direction with respect to each other. There is a traditional method which can simplify the understanding of this concept. Let t be the time taken at which both the trains meet with each other. Let capital T be the time at which both the trains meet with each other. We know that distance traveled by the first train is equal to speed of the first train multiplied by time, which we assume as S1t. Similarly, the distance covered by the second train can be written as d is equal to S2 of t minus n. Here instead of 1, assume it as n, t minus n, where n denotes the number of hours difference between the starting time of the first train and that of the second train. We know that distance when both the trains will meet each other is equal to distance travelled by first train plus distance travelled by second train. Therefore, capital D is equal to S1t plus S2 of t minus n will give the concerned time at which both the trains meet with each other. Here capital D refers to the distance between both the stations. So once we find the values, we can substitute in equation 1 or 2 and get the distance at which both the trains meet with each other. Two stations P and Q are 110 km apart on a straight track. One train starts from P at 7 a.m. and travels towards Q at 20 km per hour. Another train starts from Q at 8 a.m. and travels towards P at a speed of 25 km per hour. At what time will they meet? So first let us draw a pictorial representation of this example. Let this point be P and this point be Q. Let the distance between P and Q be small d, which is equal to 110 kilometers. Now, one train starts from P at 7 a.m. and another train starts from Q at 8 a.m. At one in between point of R, both the trains meet with each other. Let R be the point at which both the trains meet with each other. Now we need to find at what time will both the trains reach R and meet with respect to each other. So it is given that D is equal to 110 kilometers. S1 is equal to 20 km per hour. S2 is equal to 25 km per hour. And the time difference between the starting point of the first train and that of second train, n is equal to 1 hour. We know that distance traveled is equal to speed into time. Therefore, distance traveled by train 1 equal to S1t, which is equal to 20t. The value of t only we are going to compute. Then distance traveled by train 2 equal to S2t, which is equal to 25 of t minus n, which is equal to 25 of t minus 1, that is equation 2. We know that total distance traveled is equal to 1 plus 2, which will give 20t plus 25 of t minus 1. It has been given in the question as 110. Therefore, on equating, we get t equal to 135 by 45, which is equal to 3 hours. So, had we arrived at the answer? No. So, everyone will get confused that whether to add t with respect to P or Q. Always remember that you have to add the time, that is t equal to 3 hours, with the train which starts at first. Therefore, both trains meet at 10 a.m. since 7 a.m. plus 3 hours. If you want to calculate the distance, substitute the value of t in equation 1. We get d1 is equal to s1t, which is equal to 20 into 3, which is equal to 60 kilometers. So, both the trains meet at a distance of 60 kilometers from P towards Q at 10 a.m. Let us solve one more example to understand this concept. Two stations P and Q are 160 km apart on a straight track. One train starts from P at 8 a.m. and travels at a speed of 30 km per hour towards Q. Another train starts from Q at 9 a.m. and travels towards P at a speed of 35 km per hour. At what time will they meet? So we can understand from the question that D is equal to 160 km. Let us draw a pictorial representation first. Let this point be P and this point be Q. Let the distance between them be 160. Now, both the trains have traveled to a distance R. We need to find at what time does both the trains meet at the point R and at what distance with respect to P both the trains meet at R. So from the question D equal to 160 kilometer, let the time difference between the starting time of the first train and second train N is equal to 1 hour. Let S1 is equal to 30 kilometer per hour and S2 is equal to 35 kilometer per hour. We know that distance covered by train 1 is equal to S1t, that is equivalent to 30t. Let this be first equation. Let distance covered by train 2 equal to S2 of t minus n, which is equal to 35 of t minus 1, be equation 2. We know that we know that total distance is equal to 1 plus 2, which implies 160 is equal to 30t plus 35 of t minus 1, which gives 65t minus 35 is equal to 160. Therefore, on solving we get 125 is equal to 65t, t equal to 125 by 65. I'm sorry here. So this will get added. This will become 195. So 195 equal to 65t. 65t, therefore t is equal to 195 by 65, which will give us 3 hours. So instead of adding here, I subtracted it. So 195 is equal to 65t. T equal to 195 by 65, which is equal to 3 hours. So the time at which both trains meet is equal to 11 a.m. That is 8 a.m. plus 3 hours, and distance d1 equal to s1t, which in turn can be calculated as 90 kilometers. Therefore, both the trains meet at a distance of 90 kilometers from P at 11 a.m. Through this video, I am pretty much sure that the listeners would have learned how the speed, distance travel and time taken gets related with each other when two trains cross each other, when two trains move in same direction and when two trains move in opposite directions. I insist all the listeners to practice solving more and more problems so that they can increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can also be benefited. Until we meet in the next video, thank you.